So in our syllabus, we need to be able to deduce compounds that are actually involved in a reaction pathway. We need to be able to deduce the intermediaries, the conditions, the reagents that are actually involved, and do that for up to 2 steps. So this is an example from the 2018 Victorian chemistry exam. We've been given some information about a reaction pathway for the synthesis of compound P. So we've been told we start with an unknown compound M, that it forms an intermediary product of propan-1-ol by adding water and acidified environment. We've been told it then needs some reagents to make a carboxylic acid, then combines with ethanamine in an aqueous high temperature environment to form its final product. So the questions we're asked is identify the starting substance, compound M, by writing its semi-structural formula in the box provided. So semi-structural formula is the same as our condensed structural formula. So we need to use the clues that we've been given. So we've been told the product and we've been told the conditions. Now alcohols are able to be made from our haloalkanes, but they're also able to be made by alkenes. So haloalkanes we would need sodium hydroxide, whereas our alkenes we need water, strong acid, and heat and pressure. So it's going to be coming from an alkene. To work out which alkene, I use the front of my prefix of prop. So we know prop is 3. So I'm going to have 3 carbons, and it's going to have a double bond in between the first and second carbon because it's a 1-ol. However, this is a extended structural formula if I added the hydrogens in. So I can use that as a guide. So I can say, well, this has 2, I need 2 hydrogens left. This carbon here has 3. So it's going to need 1 extra hydrogen, and the final carbon has only 1 bond, so it's going to need 3 hydrogens. So once I've actually worked that out, I then need to write it as its condensed structural formula, which I can write from left to right or right to left. It doesn't make a difference because it's not going to affect its numbering with only a 1. So we have our CH2, we have our CH, and we have our CH3. So you can write it without the double bond showing. Some people actually like to put the double bond in. Or if I wrote it from right to left, it would be a CH3 starting, then a CH and a CH2. Or again with the double bond, CH3, CH double bond, CH2. So this is our first. So making sure you look at the clues that you've been given and remembering the conditions required to actually form our alcohols. So if you have an acid, it's come from an alkene. If you have a base, it's come from a haloalkane. So the NaOH. So the second question we're then asked is identify the reagents needed to convert propan-1-ol to propanoic acid by writing the chemical formulas of the reagents in the box provided. So here, if I'd just written the names, I wouldn't have been answering the question. I have to write the chemical formula, and it's giving us a hint that there may be actually more than one reagent. So to convert from propan-1-ol, which is an alcohol, primary alcohol, to a carboxylic acid, we need to actually oxidize with an oxidizing agent. And our oxidizing agents need to be acidified. So we're going to have hydrogen ions present, and we can then write either one of our oxidizing agents. So it can be potassium dichromate, which is our K2, Cr2O7, sorry, and it's aqueous. Let's just fix that. Or it can be our potassium manganate, which is a KMnO4, and again our aqueous. So either of these, and just making sure that you actually follow the instructions, which is to put it in the box. So ensure your full answer is in the box. The last question, when the carboxylic acid is mixed with ethanamine in an acidified high temperature environment, compound P is formed. Write the semi-structural formula of compound P in the box provided. So again, the condensed structural formula of compound P. So when I have a carboxylic acid, so in this case it was my CH3, CH2, COOH, and I have an amine, in this case ethanamine, the OH from the carboxylic acid and one of the H's from here combine to make my H2O, and then my two parts here combine to actually form an amide. So I've got to remember that the carboxylic acid end is going to stay attached to the C double bond O, and the amine is still going to have one of its hydrogens because it only drops a second, and it's then going to be attached to the other part, which was my CH2, CH3. So this part, in terms of your amide or peptide bond, is the C double bond ONH, or the C double bond ON, will always be in the middle, and then we have our carboxylic acid end and our amine end. So whatever the N was bonded to, it then is able to form with that. So we can then write our condensed structural formula of CH3, CH2, C, and you could write it as O, but I'm going to put the double bond in to show it clearly, and then my NH, CH2, CH3, or you could have written CH3, CH2, CO, NH, CH2, CH3. So we need to make sure when we're answering any reactants or reaction pathway questions that we're really careful in terms of looking what our conditions are, looking at the clues that we've been given in terms of intermediaries or beginning compounds or reactants that are actually involved to help us in terms of working out the information that's required.